Hey, this is James Thornock, and this is the Coder Kids podcast. Thank you for joining us today. Today on the podcast, we'll be talking about education, computer science, and mathematics. So, on the program today, we have Dr. Aditya Nagrath. He has a PhD in math and computer science, which is just a deadly duo. You gotta love that. He has experience as a software engineer at the educational giant Pearson and a contagious passion for mathematics. Welcome to the program.
Hi, thanks for having me.
Yeah, absolutely. So, we like to start where it all started for you. What on earth possessed you to study computer science and mathematics? Was it always like that growing up for you? Was there a particular device or something that got you interested in coding, or play that out for us?
Yeah, sure. So, um, I kind of started out taking all the computer science courses that they had to offer at the middle school I was at. Um, it was typing, and I think
Mm-hmm.
it was like that word processor, and like Mac 1.0 or whatever. They
Yeah.
had the Apple II GSs in the lab in the a lab in the back. So on the third year of middle school, I say it was some sort of computer science course I could take. And what the guy did was he handed me a book on BASIC. And basically, you flip on an Apple II GS and you can start typing BASIC in there and you can save it to a little disk. And then when you put the disk in, it'll just run
Mm-hmm.
it.
Have you
And
taken floppies? I'm imagining. Yeah. Okay.
yeah, I think they had the 3.5 at the time, but these are the 5.5 Apple IIs. And
Those things were giant. I remember those as a kid. Yeah, because that's the only time I've really seen them in person. With these giant magnetic floppy disks that had a spinning disk inside, which is why they're called disks, but susceptible to like memory errors and magnets and all sorts of stuff.
this is
Just for
exactly what it
context,
was.
yeah.
Yeah. And then, so then after that, all of a sudden, like maybe 4 or 5 students showed up. But it was the same sort of deal. It's like, here, here's a book. And so the next year, I kind of thought, well, I got to figure out how do I progress. There was no computer science courses in the high school I was in, 94. So I found a book over at Barnes and Nobles. It was Borland C++. It had a little CD. You pop in the CD. It teaches you the syntax for C++ and how to code and etc.
You learned
So
it
I
the hard
did.
way. I mean, that's what it sounds like.
Yeah. From there, I had to figure out what to code because, like, after you learn how to code, then it's like, well, what do you code? So I went down to Barnes and Nobles. See a little pattern here in Pueblo, Colorado.
That's funny.
Um, I went down to Barnes and Nobles and I found this book on game programming, and I found this other book on neural networks. Two books on AI neural network type stuff. And now they had the 3.5 inch in CDs, right? So like progressed. Um, but I brought those back, and I was just kind of reading those, and all was kind of a little bit under my head. But you know what it was? It was all mathematics is the thing. So like neural networks. Um, what I learned was like these back propagation networks are all matrix multiplication type operations. So I'm not surprised now that the GPUs are making this go very fast. And the computer graphics were the same thing. But like what's the cool thing about graphics is you can see the result of what you're doing.
Yeah, yeah.
Very satisfying. So I wanted to do graphics. So I got into college, and I had a fair amount of experience by that point. I guess in high school, I had done a project for the biology teacher. I don't know, like some sort of weird project where we finagled in that like me and two other people could build like this evolution game. So like um, the other kid went to MIT and like he came up with like this equation. I don't know how he did it, but he came up with this equation for evolution. Maybe he got it from a book. Maybe he came up with it. I'm not sure.
Huh.
But I programmed it up, and then like I built the whole thing around it, and I built some graphics library, etc. It was the hack that the computer graphics book at the time was like, yeah, if you do this thing, then you could program Wolfenstein. This is like straight to the frame buffer. And but
Wow.
we drew out these things, and they would evolve over time. You'd say like, yeah, go run 1,000 years, and then you come back and you take a look at these creatures that had been created through the through the equation this guy had built.
That is some wild stuff. I've never heard any story quite like that. It's got to be real. I mean, I don't think you could have made that up. So, wow. That is so it had a hack for like to put in Wolfenstein? I mean,
So like the what it was on Windows. I remember it was like interrupt 17, and it was like some weird like piece of code. I can't even really remember, but it was like if you do this thing, if you call interrupt 17, then you get access to the frame buffer. And then like the game programming book basically built up from there. It was like double buffering, right? Because like basically you got a big array which represents the pixels on the screen, and you got to light up the pixels. So then like how do you draw a line? How do you blitz stuff to the screen using the bitmaps? And how do you how do you make it faster? Double buffering, right? Because like while it's drawing, the processor is filling up the next frame buffer. That kind of stuff. They didn't have graphics cards back then. Now I'm sure it's more you're pushing the libraries for the graphics cards.
yeah, yeah. And graphics cards are
OpenGL.
still there's more demand than there is supply right now. So obviously our heart goes out to all those still trying to get a 3080 or a 3070. I was I was able to snag a 3070 after much patience and my friend writing a bot in Python to alert me when Newegg had one in stock. But we're probably getting a bit into the weeds. My bad here. So you've created this thing. This was a project in college then that you were talking about with the evolution, or
No, that was in high school. In
that was still in high
college,
school. Okay.
um, I mean, I don't know if you want to keep hearing this story or not. I'll keep going.
I'm actually
Um,
interested because this is it. Yeah.
I went to college, and then basically for computer science, they skipped me to data structures and algorithms because I drew a backpropagation network for the professor who was trying to do the evaluation. I said, I've done things like this. And he's like, well, have you done this? I was like, no, I don't know what that is. There's a linked list. And so he's like, so you need to be in data structures and algorithms. So they jumped me out of the introductory courses. And I mean, so yeah, I did the undergrad in about 3 years because of that. And I did math because, I mean, you basically had to get a minor in math. And it was like, well, what's another 20 credits? And then I also got a minor in philosophy, which was actually the same stuff. And I was like doing speech and debate at the same time in high school. So there's like, that's also kind of a logical game. Well, what I didn't like about philosophy per se was that they couldn't really agree upon the definitions of the words. And it's like, well, if you can't figure out the assumptions, what are you gonna be able to do from that, right?
Yeah. Yeah.
So I like math and I liked computer science because it's pretty straightforward.
That is hilarious. So, I mean, is there any part of philosophy that you liked? I actually also got a minor in philosophy, so that's why I'm asking.
Well, yeah, I liked the logical argument. See, right? So it's like, and then if you look at it, right, then all three things are kind of the same thing, right? You're playing with logic, but in different ways. In math to prove these theorems, in philosophy to prove things about love or knowledge or whatever, but like based on the definition of how,
Yeah.
I mean, I guess you decided to define it to start with. And then computer science being like, how do you use that to get a computer to do the mathematical thing that you're trying to get it to do?
Yeah, yeah, you're absolutely right. And the philosophy was kind of the start of all of Western civilization's educational system in general. So they're just trying to figure out the world, and is kind of a mess. And you're right. Like when you can't agree on the definitions of words. I imagine you're probably not one for politics in 2021. So all the definitions are out the window, and everything means nothing, and nothing means everything. But so let's talk a little bit about your career. Let's talk about elephant learning. I don't think I've even said those words yet. So obviously, if you're on YouTube, you've been seeing his elephant learning logo the whole video so far. But if you're just listening to the podcast, what I failed to mention in the intro is that Dr. Nagrath is the head honcho at Elephant Learning, and he runs this math program. So tell me a little bit about the program and why you think it might be useful to parents who who are interested in getting some math education for their children.
Yeah, well, okay. So on average, children in our system learn a year and a half of math over the course of 10 weeks when they use our system just under 30 minutes per week. So that's why we guarantee your child will learn at least a year of math if they use our system just 30 minutes per week over the course of 3 months. So we extended the time a little bit. And yeah, if they don't do that, we'll give you your money back, or we'll get on the phone with you. We'll do anything that we can to get you to goal. Our only mission is to help our only gish just our only mission is to empower children with mathematics.
Well, right on. I mean, as somebody who runs a business myself, I think I would prefer parents to call like at the beginning and say, hey, I noticed this thing was working or this thing wasn't working, and then you can kind of work out through the 3 months, right? Instead of like at the end. Although we're happy to fix it at any time.
We have the phone lines open.
Yeah.
I hope they call, but like, if you don't call beforehand and you just want the money back, we'll give it to you.
Yeah. So, so you're talking about quite a bit of math in seemed like a short period of time. What do you think is the difference between what you do and a public school, and why is it so much shorter of a time? Because at first when I heard that claim, I was thinking like, oh, okay, they're pre-assuming like an hour a day. And it's like, no, 30 minutes per week. You're like, well, wait a second. And then I thought back to my own mathematics experience in public school and just a pinch of homeschool, but it was mostly public school for me. And I remember either being like getting stuff instantly or not getting it at all, and kind of nowhere in between. That was my experience. And so, basically up through algebra, I got everything. Geometry was a bit harder. And, but, whether it was an algebra or something else, if I got something, I got it. If I didn't, I just had to stay after class and have a one-on-one with the teacher. And fortunately I had nice instructors who were patient and kind of went above and beyond. But, and it felt like there was just a lot of time wasted in between, because I knew that when I got it was either after or before certain kids in the class, and then the teacher would go on for like another hour or something. So is that commensurate with the experiences that the public school is still doing, or you probably know more about this stuff now?
Well, so what we understand is that it's the level of understanding of the student, and the majority of students sort of come into kindergarten not understanding the kindergarten teacher, and it's a prerequisite difference. It's a gap between what the parent believes if we're even told. I don't know. My kid's about to go into kindergarten. No one's come up to me and be like, here's what your kid needs to know, right? But like
just the like kindergarten,
welcome. No, but like the kindergarten, the prerequisite is you need to be able to count to 10. And for the parent, that means saying the numbers 1 through 10. And that's what I thought when I started this project. But for kindergarten, it's give me 10 things, and the child's able to slide over 10 and stop on 10, and they know what you're talking about. That's the proof, is they're able to do that. So that gap kind of just exacerbates over time, is what it is. Like, you don't understand the teacher, but you move from kindergarten to first grade, and it keeps going. And so like we lose, I think, 75% of students around fractions, percentage, and decimals, because before that you can memorize your way to there. Now you have to memorize processes, but you maybe don't understand what's written, what it means, or why. And I mean, honestly, it's just not a great experience for most students because of that, right? Because math actually is fun when you understand the teacher. And that's actually what most of the parents coming out of our system are reporting, is that their children are more confident and they actually enjoy math class now. Because go figure, if you can understand what the teacher is saying, maybe it's actually entertaining. The way we do that is we focus on the concepts, and we also focus on the order of the concepts. So like there's a lot of people out there saying now that like math is sort of like a brick wall, and if you're missing a piece, it's not stable. And it's kind of what it is, right? Like one idea builds on top of another idea. You have to kind of understand uh, the idea of the numbers in order to understand the ideas of addition, and in order to understand the ideas of multiplication, and it keeps going. And so that's actually kind of what mathematicians are good at, because when we're writing our papers, we're taking the terms that are the definitions or the assumptions that we're starting with, and we're writing it out very carefully to build up to the theorem that we're trying to prove. So this was built by mathematicians out of pure love of just, can we fill the gap in the system? Can we just get a first grader? Sorry, can we get a third grader whose understanding of math is really at a first grade level, and give them those ideas in that language so that they could participate at the third grade level, even if maybe they don't remember all of the processes that got them there, because maybe they're not as important as being able to pull out of a calculator and punch in the thing, which is where we're losing most students right now.
Okay, so you're saying that the problem really lies in the difference of even just language, just being able to understand the teacher and what's going on, and then the aspect of just pushing a child to the next grade and saying like, well, they passed it, they filled in the number, they didn't necessarily know how they got there, but they got there, and so they're just going to move on.
One of the fundamental, I'm sorry to jump in like that.
No.
One of the fundamental differences between us and Europe is that if you don't understand first grade math in Europe, you retake first grade math. And here there is this culture of, well, if you fail a kid in first grade, how are they going to feel? So the integrity of the system is a little bit compromised. I mean, that's not 100% of the issue, but it's part of the issue. The other part of the issue is that we do use mnemonics to try to get the student through, because passing the test is the goal, which, I mean, I can understand why it's set up that way, being a business owner. But right now we're seeing the side effects and consequences of this. So like traditionally, the way you would determine if the student understands an idea is by giving them word problems. So can they actually apply the idea of addition or multiplication or fractions to solve this scenario? And when we give them the mnemonic, and I mean, like on the test, it's only addition, it's not multiplication. You know what I mean? So like once you've given the mnemonic, you don't know if they're solving it because they understand or because they're applying the mnemonic. And children get good at memorizing which mnemonic to, right? It becomes a little computer algorithm rather than a true understanding of what's happening underneath. And that's what they're telling us, is that math is memorization. Parents are leaving these comments on my Facebook ads.
Wow. Yeah. So that is pretty incredible. I mean, we're pretty deep into this podcast. I mean, we're at like something like we're plus 40 episodes, and a lot of them have been talking about the educational system and the good parts of it and the bad parts of it, and it's clearly optimized for testing, right? So, and that is clearly what is happening. And there are benefits to that. There's a lot of data to be had and analyzed, and that's useful. But it kind of like test as God isn't exactly a good concept in it, and it can lead to a lot of negative outcomes where you're just fishing for a number once, instead of a mastery.
The bonuses or the compensation being tied somehow to the test score, which then sort of causes maybe this oversight, right? It's not necessarily anyone's trying to do anything wrong.
Yeah.
right? They just believe, well, like better test score means it's better, right? So we give them the mnemonic, but like that is one of the challenges, right? So like a lot of people ask us in our system, well, why don't you give an explanation, right? Now, we get up to algebra, it's a little bit different. We do kind of start to give explanations, and I think maybe some of the complaints are there. So we're revising that particular curriculum right now. But the question gets asked is, why don't you give them some sort of explanation on how to solve the problem? I mean, we're talking about questions where it looks like, give me 5 things, give me 4 more things. How many things do I have? Well, the hint is count them,
Yeah.
right? I mean, after you count them enough times, guess what? You're not going to continue to count them. You believe it's 9.
Yeah. Yeah.
That's unfortunately, there's no other way to do it except to have the experience repeatedly to where you just trust the addition tables. So, we provide that to the student in a very effective manner. Just 10 minutes per day, 3 days per week. We've seen students as young as 4 understand fractions, find 1/4 on a line, find 1/4 in an area, sort of type questions, which if you showed it to educators, they're struggling getting 4th or 5th graders to do that.
Oh, absolutely. Yeah. And so where we're trying to teach code to kids, right? On a regular basis, right? So we're working not with identical concepts, but fairly similar concepts and roughly similar parts of the brain. Coding can encompass quite a bit, not just math, but you're right. I do think we underestimate, and part of this could come from the school system, but part of this could just come from the fact that education is getting better all the time, and but maybe we're not using the best forms of it, I guess, which could include.
Well, I mean, it's a challenging problem from the perspective of the teacher, because to determine understanding, it really has to be a conversation. And when you're 30 to 40 on one, it's really hard. That's where a system like ours helps, right? Because we will maintain that hoop for you of the understanding, given that you might not be giving a mnemonic to solve that particular question. We give the recommendation to the parent and the teacher on how to work with the student to facilitate understanding. I'm going to give it to you here today, because if the listeners walk away with one thing, it's the why method, because it's just so effective. In fact, it's the one thing that I've got that's just, it's magic. I don't know. You can't say it, can't find the adjective. Anyway, when the student answers something incorrectly, let them do it. Don't try to stop them. Don't try to give them a mnemonic. Ask them why they think the answer is the right answer. And typically when they tell you that, you're going to see what they don't understand. You're either going to be able to devise a hint, or you're going to be able to distinguish the words. I'm going to give you a concrete example so that you can understand kind of what I'm talking about. And I'm not going to do it within our system just for fun. So I have a buddy of mine whose kids went through my system, and at the same time, I mean, obviously he was talking to me. So I told him about this why method. And he had a day where his daughter was having some challenges with the subtraction problem. Mm-hmm. And what he learned from the why method was that she had conflated the ideas of older and taller. And so this became like where he originally thought, oh, this is a math issue, it was actually something else. So you can see, like, you can use this anywhere. It's really like a very powerful method that you can apply, so long as you have enough safety and trust for the student to tell you the honest reason why they think that's the right answer.
That's interesting. I almost wish that more people would conflate those two, because I'm pretty short, so it'd be good to be young for a long time. But no, I heard you give that example on another podcast, and it really makes sense. And when I heard that the first time you said that, it just made me think, like, there's no way as a teacher, like, you'd guess that without asking why and allowing a student to actually explain the reasoning. There's no way you'd guess, like, that they'd conflated 2 words like that. You're just like, it's impossible.
It's hard to do, right? And I mean, from the way we designed the activities, we had at one point thought that we could do that if we wanted to, but we chose against it for this particular reason, which is that with high probability, we could guess what the misconception is, but not at 100% rate. And the thing is that like the reason why the math education is so frustrating is because of that gap in understanding. So like if you've got a student that's math anxious, well, if I give them the wrong video, that's it, right? Like, okay, that's it. I'm not doing this anymore. I still don't get it.
It's like me and piano as a kid.
Yeah, but if the parent sits down with you and finds out exactly what you don't understand and clarifies the idea, and now you get it and you got that aha moment, well, you're sticking with this. You're in. You just got the ball in the hoop.
Yeah. Yeah. Yeah, that's absolutely right. This happens with coding too. I have experience, and so I can attest to this Y method, but I didn't know it had a name. I'm glad to know it has a name. But I'd sit down and I'd ask a kid to explain how they accomplish something. Sometimes I did this when I literally didn't understand what they had done. And with coding, it's a little bit different because there are multiple right answers. There are like a couple different right ways to do things. And I learned a couple of times from students different ways to do things. Maybe they were more inefficient than what I was thinking of. And at least once it was more efficient than the way that I was thinking. And if I just would have looked at their screen, I would have said, no, you're doing it wrong because your code's not exactly the same as my code. And that would have been a missed opportunity for me. And it would have been like kind of poisoning the mood because they'd actually done something properly. And so, the asking of why is really important. And I also think the more specific that you can be with the why question, the better as well. Like, why did you use this particular code with this sprite? Or why did you put this number there? And they can explain more specifically. Sometimes, I guess children and adults are paralyzed when questions are too vague and too broad. The more specific, in some instances, it can be helpful. Do you feel like that's true with the why approach?
Well, so like with us, like it's either a multiple choice answer. I mean, like what the answer is, right? You're asking why do you think that answer that you put in is the correct answer? So they're going to give you the methodology, right, of what they were thinking to get there, hopefully, right? And I mean, you're saying this thing, and I got to jump in and say this because, like, if I can do this, then I mean, everyone's going to be happier. The coding and the mathematics are actually the same language. It's just a different kind of audience. The code itself, right? I mean, you're writing functions. Functions are an algebraic object. The problem is that there's syntax, right? So like code has syntax and written mathematics. Well, I mean, you got grammar, right? Like it's human language.
Yeah.
We're communicating in English or whatever language, and then we're throwing in, equations typically on the board or on a piece of paper or something, right? I mean, it's typically written. Even when you're collaborating, you're typically writing it down.
Yeah.
You might be talking while you're doing it, but you're writing it down.
Yeah, that's absolutely true. So you've got elephant learning. Parents can advance quite a bit in this, this space of time. What happens after? What's that?
You said the parents can advance as the children are advancing.
Oh, okay. Well, parents can sign up too, right?
The parents are signing up.
If you got trouble with your personal budget, you sign up. Yeah, that was definitely a slip, but
don't worry.
If you feel embarrassed about not knowing math, guess what? No one's gonna know if you sign up for elephant learning. So
we're adding more curriculum. So once we add algebra. The idea is we're doing algebra and coding is what we're doing. So it's algebra. And then we thought, like, if I could teach coding at the same time, then we can disambiguate it in the student's head. So, like, when you break it down, right, you're still using the equal sign.
Sure.
It's just in one context, it's assignment. In another context, you write it twice and it's a comparison. Right, so like we're overcoming through syntax, the the ambiguity that would exist in the written mathematics through human communication, where you're building the context around it, potentially in a book, right, or in a paper, or on the board speaking. And so what we're hoping is that this will make it so that when the student, or, we're hoping to be able to recover students in the university level, so the student is in the classroom, they're not going to feel so silly raising their hand and saying, well, what do you mean when you write that there? Right? Because it's a symbol on a board somewhere, which someone had to give you a definition for. It's not innate. And that's the problem, is that at the level of the student, the fear is that this was supposed to be innate. If I don't get this, that means something about me, and it doesn't.
Interesting. Yeah. Yeah, and that can be really tough if you're in a public schools situation or any kind of social situation where you feel like I'm the only one that doesn't get it, and often if you don't get it, actually someone else in the room probably also doesn't get it as well. So I want to ask you about the application of the software. I'm assuming it's online, the games and the whole system. Okay. And do you think mostly applicable in a public school setting, a charter school, private school, homeschool? Is it applicable in all settings? How does it work?
Yeah. So I set out, to empower children with mathematics. The idea was we had to build an effective tool to do that. Coming in, we're already like 2 or 3 grades worth of activities that were built. But basically, what we did was we built something that could fill that gap for society. So it's deliverable via web, Chrome, Safari. And basically, we try to figure out the student's initial level. If they're older than 5, if they're less than 5, we do it by the averages. And we allow the parent to adjust it because, some students are further behind or some students are ahead, right? So you can set it ahead.
Yeah.
Set the testing level ahead. But we will ensure that they understand the topics, and whatever topic they don't understand, we assign them that topic, and we give the parent the latest in the early age education practices, basically what would be continuing education. So we gave that also then to the teacher. So after we finished the parent version of this, which will help 3 or 4 students, we did something for the teacher where if they had a classroom full of 30 students, we'd be able to tell them what are the levels of all 30 and give them that same information at the student's level, which, if you got a 3rd grade teacher, they're taking continuing education in 3rd grade, well, then they're not getting the best practices for 2nd grade, right? And that's the challenge, is that the students at the 2nd grade understanding level, you got to build them that little bit. So like we're giving that to them. We'll do anything to try to solve this math problem. At the end of the day, this is about, can we get more students into college that understand mathematics? Because it's the STEM majors and the business majors where the money is in the economy.
Yeah.
And at a 69% rate, we see students moving out of STEM, out of business, into the humanities, which, that's okay. But the economic issue is that the salaries are capped. And so, if you're on student loans, that's why you have people like Elizabeth Warren saying things like, let's forgive the student loans, because to be honest, the students feel duped, right? It feels like we lied to them. You got to go to college and get a job. And they didn't have the language necessary to make that happen in college.
Yeah. As someone who graduated, in as a history major, philosophy minor, I have to kind of agree. Fortunately, I didn't go to a super, super expensive place, right? And so I don't have student debt right now, so I'm extremely fortunate. But college as the end all be all, or all degrees are created equal. I think people are seeing that falling apart for them. But
it's a sadder story than that, because I meet parents who say, now that you've told me that, in a way, right? Like the empathy of the situation, right? Like this just happened. That's what it is.
Yeah.
wish it was different. I'm trying to make it different, but like they
Sure.
come to me, they tell me like, you know what? Now that you've said that to me, I wanted to be a physics major, and it was all differential equations, and so I became an English major. And I mean, like the arc of the life of that person, right? We gave them the dream. We told them in America, you can grow up to be anything that you want. And I mean, we straight up lied. It was over in preschool.
Yeah.
The data shows that none of these kids catch up. It's the lines are basically flat. The percentile at which you enter is the percentile at which you leave the education system. And it's because we just can't go back and fill in that language.
That's interesting. Well, I really hope that, you can definitely keep making this change and, be a positive force in the educational system. Us guys in education are a bit of a minority. There's not a ton of people. I think there are a ton of teachers and lots of school administrators that are trying to do their best. And I think oftentimes we see that the system has kind of got their hands tied. It's not necessarily, it's kind of what you said earlier. No one's really ill-intentioned. Like no one's trying to mess kids up, and no one's, there's no kind of like comic book evil villain that's like behind the scenes or anything. I think all teachers.
Maybe woke math.
What's that?
The way Fox News paints woke math's pretty sounds kind of evil, but that's not what it ended up being.
I haven't even heard of this, so I'll have to trust you on that. But I am interested, and part of the reason we do this podcast is so we can find these hidden gems in education, help parents get ahead, or just find useful resources. And it really does sound like Elephant is one of these out there. Whether you're in a traditional school, public or a charter, or well, I guess public charter or private or homeschool, right? Or whether you take school on the moon. I guess it doesn't matter. As long as you have an internet connection and a web browser, whether that's Safari, Chrome, Brave, which is my preference. Whatever.
In English mainly. That's the only.
Right.
If you're not speaking English, it's gonna be. Well, I mean, you can learn math English, right? Like English math. The papers are mainly written in English. I saw one in French once.
Well, there you go. Well, thank you so much for coming on the program. Is there anything else that you'd want to share with parents that you haven't already, or where they can reach out to you?
Well, just check us out on elephantlearning.com. Where if you Google Elephant Learning, we're probably the first thing. But that's where you get started, and we'd be happy to help your children be empowered by mathematics. Right
on. Well, thank you so much for joining us, and let me know when you have adult curriculum so what I said can be true. But and their icon looks like a little kind of baby elephant with it's some kind of crimson orb it's holding. What is that?
I thought it was a ball. I don't know.
Sure. Okay, it's a ball. It's a really shiny ball. Anyway,
it's a really shiny
that's what
ball,
it looks like to the people that are listening. Well, thank you so much. And, any kind of, way to find them there is going to be in the show notes, elephantlearning.com. And then how is best to contact you? Emails, Twitter, is just through the website?
We have, we have phone lines open now. So if you guys communicate with us, we're happy to communicate with you. We're happy to do anything we can. We're open by email. You can direct message us on Facebook. You can, I don't think we got a Twitter. It's just too much noise over there.
Fair enough. All right. Well, thank you so much.
Happy to be here. Thank you for having me.